This is section 14.2, part 2. We're going to finish the notes for section 14.2. We're going to be talking about the monotonicity criterion. If a candidate wins an election, and in a re-election the only changes are changes that favor the candidate, then that candidate should win the re-election. That would be fair. For example, we have 58 members of the Student Activity Council, and they need to elect a keynote speaker to launch Student Involvement Week. So here are our choices. We've got Bill Gates, and we're going to call him G, Howard Stern, S, and Oprah Winfrey, W. So first thing we're going to do is hold a straw vote. A straw vote is kind of like a fake vote where people say who they are going to vote for, but it's non-binding. In other words, the results don't really count for anything. It's just kind of get an idea of what's going to happen with the real vote. So we have a straw vote. And in this straw vote, 8 students change their vote so that Oprah Winfrey is their first choice. And they do this for the actual vote. That's when they change their votes. We're going to use the plurality with elimination method, see who wins the first election. That's the straw vote right there. People are going to change their mind. They're going to change their results, change who they vote for. Then we're going to do the plurality with elimination method again. If the same person win, that satisfies the monotonicity criterion. If a different person wins, that would violate the monotonicity criterion. So using plurality with elimination method, remember with plurality with elimination, we are looking for a majority. So you figure out how many people are voting, and you have to have more than half of first place. If nobody has more than half, more than a majority, then you cross out or eliminate the one with the least amount of first place. So we have 58 people who are voting, and if we take half of 58, that is 29. So we need 30 people. We have to have 30 people in order to get a majority. All right. So we look at the first place. We've got W with 20, S with 16, G has 22. So even though G has the most, G does not have a majority. So we're going to eliminate the person with the least amount of first places. That would be S. So S gets eliminated from the table, and everybody moves up. Now we're going to check to see who has a majority. Well, W gets moved up here. So now W has 36 first choice votes, and G still has the 22. So what that means is, since W has a majority now that we've eliminated S is gone, then W would win. In the straw vote. Okay? So Oprah Winfrey wins the first election. Now we're going to make changes, and the only changes are going to be in favor of Oprah Winfrey. So 8 students changed their vote, so Oprah Winfrey is their first choice. So the only changes we make are in favor of Oprah Winfrey. So here we have our second real election, and now we have 28, 16, and 14. So again, we're going to use plurality with elimination. We check to see who has a majority. At this point, nobody has a majority. So we're going to check to see who has the least amount of first places. That would be G. So G gets eliminated from the table. And everybody gets moved up. So now we have W with 28 and S with 30. Well, in this case, S wins because they have a majority. So in the real election, S wins. Does this violate the criterion? Yes. You have to have the same person win both times in order for it to satisfy. And since a different person won, it violates the criterion. The final one we're going to talk about is called the irrelevant alternatives criterion. If a candidate wins an election and we recount, the only changes are that one or more of the other candidates are removed from the ballot, then that candidate should still win the election. So in other words, we've got an election, somebody knows that they're going to lose, so they drop out, and that's the only changes that are made. The person who knows they're going to lose drops out. The person that would have won to begin with should still win. So we have 4 candidates, E, F, G, and H, and they are running for mayor. Using pairwise, who wins the election? Remember, with pairwise, we have to compare everybody with everybody else. So you would compare E versus F, E and G, E with H. You would compare F with G, F with H, and finally G with H. Okay. I'm only going to do one, but you would do this for all the comparisons, and you'll see. E versus F. So remember, with pairwise, whoever is above the other one in the column gets that many votes. So E compared with F, E beats out F in the first column, so they get 160 votes. F beats E, so F gets 100 votes. E beats out F, so they get 80. And E beats out F, so they get 20 more. So as you can see, more people prefer E over F, so you give E 1 point. You would do that for all the comparisons and count up the number of points at the end and see who wins. So E ends up with 2 points. F and H get 1.5 points. To get a half point, you have a tie. So when you have a tie, you get a half point each. And H has 1 point. So using the pairwise, E would win the election. Before the results are announced, F and G know that they're going to lose, so they withdraw from the election. Okay, so F and G are gone. F and G, F and G, F and G are eliminated from the election. So now, using pairwise, who would be the winner between F and with F and G removed? Okay, so remember, E won the first time. So does E still win? So again, you would compare E versus H. Those are the only 2 people that are still in the running. E beats out H. H beats out E. H and H. Right here. So as you can see, H has more votes. H gets 1 point, so H wins. So H is the winner. And does it violate the irrelevant alternatives criterion? Yes, we had a different winner, so it violates the fairness criterion. There was an economist named Kenneth Arrow. He proved in 1951 that it is impossible to create a voting system that is completely fair. There does not exist and will never exist any democratic voting system that satisfies all four of the fairness criteria. So just so you know, it is impossible to be completely fair with the voting methods. Homework is 2 through 18 even.